let's take a look at Lab 12. Lab 12 is our final lab in Computer Science 120L, and it is using a library called Graphics Magic. Here I've got the page up from our Canvas site. The invitation link is right here in the middle. So if you click that link, accept the invitation, you're going to be able to create a repository. And there's two parts in this. And this video, I want to focus on the functions in part 1 and the functions in part 2. So let's get started with that. Let me get this out of the way. And what I've done already is I've opened up the files for part 1's functions. Now here I am in the directory with my repository, and part 1 has a whole bunch of different files. Oh, sorry. Let me clean that up, make it easy to read. So we've got a lot of files, but we really need to only focus on a few files. So this is the animated gradient functions.h. There's nothing to do here, but it's useful to read and understand the contents of this. It has the prototype for 2 functions, which are defined in animated gradient functions.cc. That's this one right here. This file has a lot of to-dos, and this is where we need to put some work in there to get it to work. There's another file called animated gradient unit test. We don't need to make any changes here, so let's close that. And then we also have animated gradient.cc. This is our main function. I'm not going to do anything here in this video, but that's where the main function is, and that's where all the work happens. But to get this project moving, we need to get these functions written. So let's start with those functions. In this function here, we want to write something that is, and I'm just organizing this, I'm reformatting it so it makes it easier for you to see how it looks. In this function, we want to see if our file name is something like image.png or image.gif, that if extension is equal to .gif, we want to be able to return true if the end of file name matches extension, and return false if it doesn't. That's the gist of it. Now, one thing that we need to recognize is that extension here is length 4, and file name is length, well, that's 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6, 7, 8, 9. So in order for us to have a file name that has the extension .gif, it has to be longer than 4. There's just no way around it that you can have a file name that's of length 4, 3, 2, or smaller and still have it end in .gif. The smallest file name that you can have would be something like a.gif or x.gif, because you need to have a file name. So you need to have the 4 plus some more letters. So that's the first thing that we want to check, is by looking at the size of these 2 strings to see that the file name is actually longer than the extension. The next part of it is that we want to do a comparison, and we're going to use a member function that you can look up on cppreference.com to compare parts of a string or a substring. First step, and I'm going to try to go through this in like a very step-by-step fashion. There's a more concise way that you can write this in a single line, but that's hard to understand for a beginner. So let's do this in a step-by-step fashion. Our first test that we want to pass is whether or not file name is longer than extension. So let's get those 2 lengths. File name length is going to be assigned a file name size. And then we have extension length. I will initialize that or assign that to extension size. Now, if you've been a good student, you've probably been doing this using initializers, and that's a good thing to do. In the video, I'm kind of like using assignment just to make it clear for everyone who has not been using initializers all the time, but the initializers are the right way to go. So anyway, we've got our file name length and our extension length, and we want to have a bool that will tell us that is it long enough. This will be true if file name length is greater than extension length. Now, if file name length is larger than extension length, is long enough will be assigned true. If file name length is shorter or equal to the extension length, it will be assigned false. Now, before we go on, we need to make an assumption. We're going to that the file name does not end in our extension. So we're going to make another bool. We'll call it has extension, and we'll initialize it to false. The reason we do this is because our next step is to say, well, if it's long enough, let's check the ending of it. But if it's not long enough, we already know that it's false, and we can just return that. So down here at the bottom, I'm going to return has extension. And then over here, I'm going to check to see if it's long enough. If it is long enough, this is where it's possible that it does end in .gif. So I'm going to do a comparison. The next hard part is like, well, I don't want to compare both strings. I only want to compare part of the string. So if I imagine I've got the file name image.gif, well, where is the period? I have to find that. And that's 0, 1, 2, 3, 4, 5, 6, 7, 8. So that string is of length 9, and I've numbered below it every single location for every letter. So the first letter I is at location 0, the last letter F is at location 8, and the period is at location 5. Well, .gif is of length 4. The period is at location 5, and image is length 9. Wouldn't you know it that 9 minus 4 is 5? So if I take the length of the extension and subtract it from the length of the file name, it'll tell me where I expect to find the period. If the period's not there, well, the comparison won't pass, but at least I've got a spot that I'm comparing it at. And because I've already verified that the strings are that the file name is longer than .gif, it's safe to compare it at that location. So let's find the period location. So that's another int period location, and we'll assign it. Well, I'm going to use the file name length minus the extension length. Once I have that, I can now do my comparison. And the way we do string comparison is I'll use the variable has. Well, let's just start with the compare. I want to say file name length dot compare, and I want to compare it against the extension. Now, what that does is it returns 0 if they're the same, and some number if it's not the same. But this compare member function is going to compare both of the strings completely. So it's going to start checking from the beginning of file name length. And I don't want that. I want to start checking from where I think the period might be. So if you look up compare in cppreference.com or a reference book on C++, you can find that you could tell where to start looking but with changing compare by giving it a location to start from. And the location I want to start from is where I expect to find the period location. And then I want to tell it how many letters do I want to compare against. Well, I want to check to see if it has the length of extension in the file name. So the length of extension is up here. That's this variable. And it's going to check 4 letters starting from period location, right? 4 letters, that's the length of the extension, starting from the period location in the string file name length against extension. So that if I've got a string like image.gif, it's going to start checking, not at the beginning, it's going to start checking here, and it's going to see if, starting from location 5, if the last 4 letters match. Now imagine if I had image.png, well, it's going to start checking from location 5, which is where the period is, and it's going to compare against .gif. And it's going to match the first letter, the dot, but it's not going to match the other letters. This one's going to return 0, and this one's going to return something other than 0. So in order to make this work, I also have to say, is it returning 0? That's a tricky thing with string comparisons in C++ is it returns 0 when they're the same. And if you remember the rule, 0 is false and everything else is true, this doesn't match how bools are defined. So it's necessary to do that comparison. Now, to finish this up, we want to save the results someplace. Again, remember, we said we're going to assume it does not have the extension. And now we have a way of knowing if it really does have the extension because we've compared it. So we're going to take this variable and modify it, if necessary, by storing the result of that comparison. Now, this will take us all the way through and check to see if our parameter file name ends with this extension. That's this entire function. The next function is where we want to build a lookup table. A lookup table is, imagine a spreadsheet. You're going to have one column with some index, and the other column will have the value that you're looking up. And what we want to look up here are values of sign values. Instead of calculating the sign value over and over and over again, instead we're just going to put it into a vector and hold on to it. So we save a little bit of time. And this is a little bit of an academic exercise, but it's a good exercise to do if you're studying how to write programs. So if you read the instructions, it's going to say, well, we've got an image that's so wide. And what we want to do is we want to divide pi evenly over the entire width of the image. So you can imagine that image width is the number 3. So that means there's 3 pixels. And if I've got pi, and remember pi is like approximately 3.14, I will divide 3.14 by 3 and get the number 1. So now I'm going to calculate the sign for 0, 1, and 2. And that's it. And I'm going to store it because that's all we need in our program. And how we use it will show up later because that's used in the main. But for this exercise, all we're going to do is we're going to take pi, divide it by image width, and then calculate the sign for every single number up to pi. So let's first figure out how many times image width goes into pi. So I'm going to declare a double, and I'll call it steps, or step. And step will be the value of m underscore pi, and that's a shortcut for pi. There's a header file up here called CMath. CMath is the C standard library header file for mathematics, and in that file they've defined pi as this macro. It's kind of like a variable, and it will be a very precise, it's not just 3.14, it's 3.14 blah blah blah, and has a whole bunch of digits there, so it's a really handy tool to use when you want to use pi in your programs. And then I'm going to divide that by image width. That gives us how many times I need to, that gives me how many steps there are from 0 all the way up to pi, given the number of pixels I have in the width of the image. But we've got a small problem here. Image width is an integer. MPi is a double. These types don't match, and to be safe, to do it right, I want to statically cast image width to a double because the types must match. Now that's safe, and image width won't be a gigantic number. It's going to be safe to cast that integer to a double. Once I have that, I'm going to write a for loop. I'll say counter, and we're going to start off at 0. And then counter is less than image width. And I'm going to increase counter by 1. And inside this loop, I'm going to take this lookup table. I'm going to add numbers into that lookup table. So I'll say I'm going to calculate a double value, a sign value, and that's going to be assigned the result of using the function sign. And the value that I'm going to give it will be counter times the step. So I'm starting from 0, and counter's going to increase 1, 2, 3, 4, on and on and on, up to, but not including image width. So that way, as it goes up, it's going to multiply against step, and it's going to start from 0 and slowly get up to pi, or almost pi, by doing all that multiplication. Every time it does that, it's going to calculate the sign value and then store it in this variable. But remember, counter is an integer and step is a double. So we want to be safe, and we're going to convert or cast the integer to a double so that we have types that match. Once I have that sign value, I'm going to take that sign value and stick it into the lookup table. And we can use the member function called pushback, which inserts that sign value into the back of the vector. And then at the end, we're going to return the lookup table, so whoever called this function would have the lookup table to use. Now, at home, when you're doing this, make sure that as you write your programs, you compile so that the compiler gives you feedback about any syntax errors that you're making, and make sure that you've got the right formatting. I'm kind of cutting corners here just so I can make this video brief. But now that I've got those two functions done, and I know I've got unit tests, remember I told you that there's this unit test file, I can use my make file and say make the unit test, and it's going to compile the unit test file, and if it's possible, and run those tests to verify I've got the correct functions. Now, I have made a mistake. Line 29. Oh, I accidentally wrote file name length. The compare is for the string, not the integer, because remember, file name is a string. I can compare them, and I had accidentally typed file name length. Let's do that one more time. So it compiles this file, the functions.cc file, compiles my unit tests, links them together, and then runs the unit tests. And you can see that there were all the tests have passed. So I've got a high degree of certainty that everything here is going to work correctly. That's great. Now, in part 2 of this project, we also have a whole bunch of files. Oops, this got built. Let me clean that up so it's easy to see. We've got the same idea with the structure of this assignment. You got your unit test, which you don't change. You got your functions.h, which have the header files, and then you got your main and make message.cc, and then you got make message functions.cc, which have your functions. I've got everything open over here. Let me make this nice and big so it's easy to read. Again, make message.cc is our main. The unit tests, you don't need to make any changes, so I'm going to close that file. The make message functions.h, good to read. That's like tells you what we're supposed to be able to use from our main. And make message functions.cc, this is where we're going to do some work. Now, in this file, we have the same function again, has matching file extension. So we're going to borrow our we're going to borrow our has matching file extension from this file. Just going to copy. So we're going to copy it. Let me just do that nice and slow. And we're going to go over to this file. This is our make message functions.cc. I'm just going to paste it. And my text editor has made a mess of the formatting, but we can fix that later. Are there any other to-dos? Okay, here's another to-do. Random double 01. Using RNG01 call next. Okay, so these functions here are using these objects over here. So on these lines here, these lines specifically, we're defining a random number generator. That's the type, random number generator. The name of the variable is RNG_01, and this object returns random numbers that are between 0 and 1, and they're doubles. This one will return random numbers between -1 and 1, and this one will return random numbers between -1 and as well. These are going to be like secret global variables that we're going to hide behind these functions. In this function here, we want to use RNG01 and return some random number. And all you have to do here is just say RNG_01 and call next. Next is the member function in that class that will give us the next random number from that random number generator. This one, random double 11, we use the other random number generator to return the next random number. And then finally with the coin flip, this one's a little bit different. This one, we're going to use this object, that variable right there, RNG coin flip, and we're going to return true if the random number is greater than 0 and false otherwise. So we use this one right here, random coin flip. So RNG coin flip. next. That gives us the next random number, but we want to return true if it is greater than 0.0 and false otherwise. If you write that, it's going to work beautifully, because if this returns a number that is greater than 0.0, like 2.5, then it's going to be true because 2.5 is greater than 0, and it's going to return true. If this piece right here that I've highlighted returns negative 5.7, well, that's less than 0.0, so that negative 5.7 is less than 0.0. That's false. So it'll return false. Now, because these are our functions, we can again use make unit test to see if we pass the unit tests that our professors have kindly provided us. Ah, wonderful. So we pass all the tests. Now, if you're wondering, how is it possible that we can test these random number generators? Are they really that random that we can have a test that will check to make sure it works correctly? We're using a little trick here. We've got this random number generator seed. RNG stands for random number generator. The random number generator seed is the same for all of us. So if we seed, and seed in the sense of like you're growing a plant. If I start the plant off with the same seed, if you use an apple seed, you get an apple tree. If you use a tomato seed, you get tomatoes. If you use some other seed, you get some other fruit. So if we start with those numbers there, 1, 2, 3, 4, 5, and seed our random number generator, then we're going to get the same results. As an example of how this can go wrong, or differently, if I seed it with some other number, it doesn't matter what it is, and I make my unit test, you'd expect that some of the tests will not pass anymore because the random number generator is different, because I've grown it differently because I used a different seed. And you can see that some of the tests don't pass, they fail. So if I put that back to the same numbers that we had earlier, make the unit test, it passes. Awesome. So this was our quick walkthrough of the two function files in our project for Lab 12. It's not too complicated. They're straightforward. It's a little tricky with the has extension. This one's easy to read. This one's a little bit tricky because there's that understanding that if I have a file name, it must be longer than the extension length. I've seen many, a very common mistake is that you don't do this check first and instead just immediately go to something like this and you look to see where the period is and try to compare it. If the input file if the input file is shorter than the .gif, it will fail. And our unit tests will check that. And that's why I'm passing all the tests. If you don't do this check, it will not it will fail one or more of the tests, or it will just abort and not give you all the nice green text saying, oh, it ran it and it's okay. So I hope that explains these functions. Give it a try yourself.